Hello, Spark fans. Welcome back to Advancing Spark. Once again, brought to you by Advancing Analytics, your local data AI engineering consultancy based in the UK, but helping out clients everywhere. So, the plan today is we're going to have a look at a thing called deletion vectors. Now, they kind of snuck in a month or so ago in terms of actually as an improvement to Delta. But it really affects lots and lots of the ways of working, lots of how we think about things, lots of how we go about doing things. When we previously go, no, don't do that. That's going to be inefficient. We can now go, nah, it's fine. It's cool. It'll just work thanks to deletion vectors. So they are pretty cool. So we're going to spend a moment, talk about what they actually are, look at how they work, run through a quick example of applying some deletion vectors and then not applying them, and where do they go, where do they look, how does it change your delta tables. That is the plan for today. As always, don't forget to like and subscribe if you're new around here. And yeah, go and have a look. So, firstly, I've got some, there is the documentation on the Databricks website, on the Delta website, all over the place. Wherever you're using Parquet and it's using the upgraded stuff, it's going to teach you how that works. So, a few bits and pieces. It's a storage optimization that does some nice stuff to do some things. That's kind of how it's explained. Much simpler way of explaining it with a picture. So if you currently have a big old Parquet file and you want to say, I want to delete that one particular record, you cannot do that. Parquet files are immutable. Once they're compressed, you can't change it. The only way to change it is to just delete it and rewrite it. So we've had this age-old problem. It's one of the reasons why Parquet was great for efficiency, but really annoying to work with, but in the days before Delta. Now, Delta comes along and automates lots of things. And if you say, delete a record from my Delta table, it'll do this. It'll essentially say, take your entire table, replace it with a new version of that table, but with a particular record missing. So this is kind of how Delta works today. So a lot of the times when you write an update statement, you write a merge statement, you write a delete statement, anything that might delete or update any information in a particular Parquet file, it will actually just go, oh, well, I'll just move all the data that hasn't changed into a new version of a file, and I'll make some changes over here, and I'll mark your existing file as removed. That's how Delta works. And now that's inefficient. You can see in here I've got 5 records that were in the original Parquet file. I've had to copy over and rewrite to disk as a new particular Parquet file. Deletion vectors is saying, well, that's a bit silly. Why don't we, instead of actually writing over the things that haven't changed, just say, make a list of all the stuff that's deleted. Now that means whenever I read from my Parquet file, I need to check that list and go, has anything been deleted? Oh yeah, okay, I should disregard those records. So your Parquet file is not changing. Parquet is still immutable. But I've now got a deletion vector file that sits alongside my Parquet going, and once you've read all that, by the way, ignore these rows. Now, makes our write a hell of a lot more efficient, makes things a lot quicker and easier to manage. There's a point when that becomes really inefficient, when I'm having to check millions of rows that have been deleted and go, okay, read 10 million rows and then disregard 9 million of them. That's not going to be particularly efficient, but that is cleaned up whenever we next rewrite that table. So your deletion vectors kind of build up against your Parquet file, and then you do a big update on, well, I'm just going to rewrite it now. All of your deletion vectors get applied and it goes away. Also, you can run some commands to go, well, actually, just now that we're not in the middle of a big ETL run, just go clean up all the deletion vectors, tidy that stuff up. So we now have a maintenance task we can do to tidy things up. So that's what we're trying to do. We're trying to tell Delta, hey, can you go and make a deletion vectors file for me? Can you apply these deletion vectors really quickly? And can you look after it for me? And the answer is yes, that's now available. So recommended to use the latest, well, the next but latest runtime. So Databricks runtime 14.0, 14.1's just been released. If you want to do everything with all optimizations and all the good stuff in there. You can read deletion vector enabled tables from 12.1. Now this is a big thing. By enabling these deletion vectors, if you're using an older version of the Delta reader, it won't know how to read them and it won't work. So whenever you create a Delta table, it has a minimum Delta table reader version and a minimum Delta table writer version. So if you're using something that is Delta compatible that can read Delta, might not be able to read this version of Delta. So be really careful. If you're using Databricks, writing a lot of Delta, that's all going to be happy as long as you're on the right runtime. But if you're then reading that data from Power BI, Tableau, Looker, if you're ingesting it into other systems, if you are using other things in the Delta ecosystem, make sure it can actually read that minimum table version. So, word of warning, this is new, not everything is compatible yet. So enabling it, we do at the table level. So when we create a table, or we can alter a table, and we can say, make enable deletion vectors equals true. And that is a one-way upgrade. So at that point, that Delta table is then of the table protocol, that is the level it needs to be. You can't move it down. Technically, you can drop it to enable some stuff, but be a little careful. Be a little careful about how it actually works. So that's the warning. Warning, not compatible with everything. Make sure you know what's going to want to read that Delta table before you do this. If you've done it, you can start playing with it. So there's a few things in here. You can just reorganize, apply, purge, is what I was saying in terms of if you have files that have started to get some deletion vectors built up, and you, in your own time, in a maintenance window, want to do that rewriting and tidy things up, you can do it. You can also just do an optimize on that table. That will also go and clean these things up, but only if those files are ripe for being optimized. If they're nice and good and compacted, it won't optimize it to get rid of any deletion vectors. So yeah, normal things. Anything that triggers a rewrite of that file is going to apply your various deletion vectors as it goes through. Other things, be careful. Delta sharing won't work with deletion vectors. That's one of those things that won't actually be able to read it yet. And if you are generating manifest files for certain integrations, that's not yet going to work. So little bit of warnings, a little bit of things to be aware of. Let's go and have a look how it actually works. So let's start by just making sure I've got things tidied up. Okay, so it's already deleted. That was good. So I'm going to create a schema. So I'm using Unity Catalog here. So I've got this managed location. So I've already created an external location. So I now have this schema, and it's going to go and create some files in my lake so I can then manage that schema. If I hop over here, we should actually see it's going to be the thing that really annoys me about Unity is because it's going to give it a weird name. So Unity storage in my schemas, you can see I've got some schemas that have been created here for me to have a play with. So if I then go, I'm just going to grab some data. I'm reading the Databricks dataset, some 10 million parquet people. And I'm going to create this new table just as a CTAS, as a create table as select from. So create a new Delta table called ppeople. Give it the property of enable deletion vectors equal true. And I'm just selecting the first million people from that parquet table. So I can test that. Do I have some data in there? I should just have a basic table. Yeah. I've got a load of data I can then start having to play with. I should now actually see I've got a new schema in here. I should have my parquet table. Sorry, my Delta table. I've got my one parquet file in there. So currently all I've got a single transaction to go and create that table. There's nothing exciting happening there. It's just added my first particular thing. You can see in here, I have enabled the reading and writing of deletion vectors. So part of that is because I set that table property, it's included those as features inside the actual initialization of my Delta table. You can also see minimum writer version, reader version are updated to show the fact that you need to be able to read deletion vectors to work. So yeah, not too much going on, but at least I know that I put the right setting in. It has actually respected the thing I've asked it to do. So quick test. Let's go and delete some more. So delete from that table where ID equals 4, single record, nice and quick. So normally, if I was doing this, I would expect it kind of to take the same amount of time as this initial, like 11 seconds. It's not that long, right? But that was largely the write of those 10 million rows. Now, normally I would have to rewrite 9,999,999 rows to show I deleted a single record. In this case, I haven't had to do that. So if we take a step back, I can get rid of this. I can go and have a look and say what's going on in my transaction log. We'll have a look in a second. But I can now see, as well as my original parquet, I've not created a new file. I've not had to copy a load of rows over, but I do have a new deletion vector bin file. So that is a small encrypted file. I can't go in there and have a look at it. That just says, essentially, this is the row that's going to be gotten rid of out of that parquet file. If we go and have a look at what's going on in our transaction log, I'm going to download it so we can read it a little bit nicer. Go. Whoops. Okay, so we can see it was me, it came in, I've added a deletion vector, I've not changed any files, I've not copied any rows, I didn't have those 9 million rows being copied over. You can see, technically it does it in terms of the Delta protocol, it does it as a remove of the old file, it then re-adds the old file back, except this time with an attached deletion vector. So it's kind of like a remove and then automatically re-add kind of thing to tell me how many deletion vectors I've got, what's actually happened inside there. So it's pretty cool. I can go and actually have a look what's happening. I can keep track of that stuff. And yeah, my table's getting better. Now I had a quick test. I did an update just for a single record. Now in this case, this did cause a rewrite of the particular file. So depending on the action that you're doing, some things will force it to go, oh, actually we need to rewrite that. We have a look what's happening here. We're going to see again, we've got the old parquet file removed and a different parquet file added. So in this case, it was like, oh no, I can't quite do it. I'm not quite sure which deletion vector I should do. It was going to have to add a new file anyway, because it had to insert the updated version of that. So in this case, it has done a copy of a load of rows going over. And it's amended my one particular thing, and it's gone through. It's also removed my deletion vector. So because it's actually saying, well, I'm going to rewrite this anyway, I'll just actually physically delete the record while I'm doing it. We don't need to worry about the old deletion vector anymore. So it's tidied up part of my data. It's updated my one row. It's pushed stuff over. I got rid of my original record, well, my second parquet file that had the deletion vector. And I've added a new parquet file that doesn't have any deletion vectors, and it's got all the remaining data in it. So yeah, that could have been more efficient. I guess I could have written a parquet file of just one record and then added a deletion vector to the other. But yeah, kind of makes sense. Now, we can go and have a look at the history. We can see what's actually going on here. So we can go and say, okay, what happened? In my operational metrics, we can see that same stuff. So we can see when I added a deletion vector, how many were removed, what actually happened in there. And then I did some testing in here. So I was having a play going, well, what actually causes something to change? So if we do, going to get rid of 50 records. So go to the first 49 records are going to be deleted 48. And then go and have a look what actually happens in there. Now, in this case, that's not many records. I want that to be part of my deletion vectors. So number of removed files, 0. That's good. Good news on our side. I've added in just one new deletion vector that's got those 48 records, deleted 48 records. Nice and efficient. Let's do a step up and go where it's under 5,000. And again, this should just be real easy. Write those into a new thing, nice and fast to go and delete those new records. I want to go and see that has been added as a new deletion vector. Absolutely. No removed files, no copied rows. It's added deletion vector, removed an old deletion vector, and now it's got 4,950 rows in a deletion vector that's held alongside my parquet file. As simple as that, really. I mean, so we can go up and up and up. So I can go, I want to get rid of 500,000. The point where when it's deleting so much of my data, I kind of assume it would go, well, let's just write a new file at that point. But I don't know why that actually lives in terms of the optimizations. Yeah, in this case, it's done it purely as a deletion vector. So I've got a deletion vector with 500,000 rows in there going, we don't need any of this. And there's a point now when it's like, would that be more efficient to write that as a new parquet file? So the next time I come and do an optimize, next time I come and do run that reorg command, it'll then go, that's a lot of deletion vectors. There's a lot of data inside a deletion vector. I'm just going to rewrite that as a nice clean parquet file and mark that's removed, and that'll be quicker going forward. And that is about it. That's all there really is to it. So deletion vectors, you just turn on a particular table. Once it's enabled, anytime you interact with that table, if it can get away with just doing a delete by marking it inside a new deletion vector, that's what it'll do. You'll start to see these bin files crop up inside of your Delta table alongside the parquet. It's treated just as another parquet file. I kind of assumed it would appear in like a lot of the things they do with Delta. There'd be like an underscore deletions kind of subfolder, but it doesn't. It just puts it in the data folder. It treats it as pure data, so your parquet and your data is still there. Again, if you're just reading the parquet files, which you should never do in a Delta table, that won't respect those deletion vectors. If you're trying to read this via an older protocol, it's going to break, because inside your Delta transaction log, it has the minimum allowed version of the Delta reader and writer. So if you're using an old version, If you're using another tool that's not yet been updated and you try and go against it, it's going to throw an error. It's not going to let you read this data. Be aware of those limitations, but as long as you're not hit by them, you're going to absolutely go ahead, and this is just going to make things a lot faster when you have really choppy, changey deletions in your data. Cool. And honestly, that's it. I've been meaning to dig into it, meaning to actually sort of share this with you guys for a little while. It's been around, as I said, for a couple of months, but just a real nice, easy to do thing. Enable it through just on your table properties. So it kind of feels more like a Unity catalog setting because you're doing it at that SQL level on the SQL part of your table. You can pass it as a property when you're first, if you're explicitly creating a Delta table, you can pass it into your properties of your PySpark when you're actually creating it to do that anyway. But yeah, as to, are you going to do this by default? Kind of depends on what you're integrating with. I think for a lot of ETL, where it's just things are being handled, being passed through, maybe. As to how many times do people actually run a delete command as opposed to a merge statement? It's going to be interesting. If you had a merge statement that was just nothing but deletes, would that actually, it should actually be much more efficient there. But then how often is that? Or is there more updates, which kind of seem tends to recreate the file anyway? It'll be really interesting to see actually, the idea is sound, makes a lot of sense. How often do people actually hit it? How much does it get triggered? But yeah, that's deletion vectors now available. Database runtime 14.0 and above is what you want to be if you want all the performance optimization stuff. And we're going to see all the predictive IO things starting to use it and starting to utilize more and more of it. And things will go faster and faster and faster. So yeah, pretty good. That's all for me. As always, don't forget to like and subscribe, and I'll catch you next time. Cheers.